Alrighty, in this video we are going to start by looking at some properties of definite integrals. Recall that a definite integral is where you have an integral with bounds, usually we say from a to b. We have a function, let's call it f of x, and we have this dx piece on the end identifying the x, in this case, as our independent variable. Okay. Later on we're going to be looking at indefinite integrals, which is where you don't see the bounds a and b. Okay, but that's chapter 6. So for now, some properties of definite integrals. So here's the first one. Okay, our first one here deals with reversing the order of our bounds. Typically you see the a in the bottom, the b in the top. Remember, the a, or the lower bound, is the smaller of the two. B is the upper bound, which is supposed to be the bigger of the two. Well, if those get reversed, if you have the bigger number on the bottom and the smaller number on the top, okay, then this is equal to the negation of turning it the way it's supposed to be, which is where a is on the bottom and b is on the top. Okay, and we'll see an example in a little bit, but just remember that if you are reversing your bounds, it's just going to equal the negation of the other way where the bounds are in the correct location. So you're always supposed to have the smaller one on the bottom, the bigger one on the top. Okay, next one should be fairly obvious for you. If we look at the bounds, notice they are not changing. So that means the value of this definite integral is going to be 0. And this should hopefully make sense to you. If the function is above the x-axis, imagine drawing a rectangle where there's no change in x value, right? So the area of that rectangle would have to be 0. All right, so if there's no change in the bounds, then the area is going to be 0. Okay, this next one here says that if we have a constant, call it k, so some number is being multiplied to the function on the inside of our integral, that is equal to taking that k and just factoring it out and putting it in front like you see right here. So think of it as we just pulled it out as like a GCF. We just pulled it out in front of the parenthesis, in this case the integral, and then you would just be left with this integral times k. Alright, so rather than dealing with it on the inside, we just pull it out and put it on the outside. Okay, next one here deals with integrating either the sum or the difference of two functions. So basically, if you have a couple different terms on your inside, this property says you can just distribute your integral to each part. Alright, so the plus or minus symbol means it could be plus or it could be minus. Alright, it's just showing the separation of the two parts. So again, it's just the idea of distributing that integral, and notice how the dx is going to show up. Whoops, the dx is going to show up 2 times here. The integral is going to show up 2 times as well because we're distributing it. Alright, so you would just treat it as 2 separate mini problems. And we have one more. Okay, our last one here says that if we have an integral from a to b plus an integral from b to c, notice how these bounds match, then that is going to equal the integral from a to c. So where you started and then where you ended. So if we're talking about a function that's positive, that's above the x-axis, think about this in terms of area. So the area from a to b plus the area from b to c is going to give you the total area from a to c. Okay, so you're just kind of putting the two smaller pieces together to get this bigger piece. So now let's look at some examples. Alright, take a moment and copy this down. Notice how there are 3 given facts involving 3 definite integrals, and we're asked to find 4 different things. So the first 2 are really quick. They don't involve really any work whatsoever. So the first one here, we're looking at bounds that go from 4 to 1 on the f of x function. Well, up here we have a given fact for the bounds going from 1 to 4. So we talked about the property where this is just going to be the negation of what we know. Alright, so that's just going to be a positive 2. Okay. The next one here, notice how the bounds are 3 to 3, so they're not changing. So anytime our bounds are not changing, we said the answer is just going to be 0 for the definite integral. Alright, next one here, we have a little bit of work to do. We want to find the total area here going from -1 to 4. Okay. Well, it helps to sketch a picture here to get a feel for what's happening. So, and we don't know exactly what this looks like, but we do know that from -1 to 1, we're told that this definite integral on f of x is 5. So what that really means, since it's a positive, we're talking about an area that is above the x-axis. So that's 5. Okay. And then we're told with this second piece of given information that the area from 1 to 4 is -2. So again, we don't know exactly what this function looks like, but we do know that when we go from 1 to 4, we have a negative definite integral, which means we have some space below the x-axis. So I'm not going to label that -2 because we know area can't be negative. I'm going to label it a +2, but because it is below the x-axis, it's going to take on a negative value here in our definite integral. So the net result, if we go from -1 to 4, that's the same as going from -1 to 1, so that would be the 5. All right, and then adding on the amount here from 1 to 4, which we know from our given is -2. So do you really need a graph to get this answer? No, of course not. But just understand that it's really referring to area above and then area below the x-axis. Okay? And then finally here, we have 3 parts here inside of this definite integral. So we talked about how we need to distribute this to each part. So let's rewrite this. Each part is going to have a dx on the end. And notice how this last part inside here is just a 5. Okay, dx. There's no f of x or h of x attached to it. So we're just going to attack this one part at a time. So this first part here, we talked about how we can pull out that 2, all right, and then really just focus on the integral from -1 to 1 of f of x, which we know is 5. The next part here, we can pull out that 3, and then just focus on what's left, which is the integral of -1 to 1 on h of x, which up here is 7. So we have 3 times 7 plus. Now this last part, if you're wondering, well, wait a minute, there's no function here. There's no f of x or h of x. We know the bounds match the given information, but the function itself doesn't. Well, we don't need the given information to figure out the answer of this definite integral. Recall that this is really from -1 to 1. The function is really 5. So y equals 5 would look like this. So we're really looking to find this area, which that rectangle would have dimensions of 2 by 5. Okay, so this would equal 10. Okay, so we're going to add on 10 more. So that's going to give us 41 for the value of our definite integral there. So those are some examples on properties. That's pretty much all that we need to cover here. See you later.